Welcome everyone to another episode of BoneHeads. I'm Ben.
I'm Hamza.
I'm Eddie.
And this is the paleontology podcast where we kind of talk about new discoveries and such and what we're up to in the world of paleontology as paleontology students ourselves. This episode got some exciting stuff happening as usual, as every week in paleontology. There's always exciting things. Yeah, we got Ankylosaurs. We've got
Dinosaurs.
more Spinosaurs because we didn't have enough last week. Got this to talk about later. We have... What else have we got today?
Therizinosaur?
Oh, Therizinosaurs, my favourite.
Have early crocs.
There's always some crocs in there somewhere. No ichthyosaurs today, which is a shame. Well, sort of, maybe. I'll take that off now. Anyway, I think we'll just go straight into it. Seems to be kind of the best way to just get started. So, you've probably seen stuff about this in the news. If you've been following any paleontology
Have you
news.
7 Days of Science?
Yeah, I did talk about it briefly. So, we may have to sign in to this if you're not signed in. Oh no, it's a... Yeah. So, yeah, you can show this. We have a paper published in... This is Nature, right? But it's Communications Biology. High-profile journal. An Ankylosaur larynx has been preserved as a fossil. This is the oldest fossil of a larynx that we have.
Yeah, by like a fair amount. I think
Yeah.
the one before this was from a Green River Formation, which is around
Yeah, so not even Mesozoic.
yeah,
Wow.
like 50 million years.
Yeah.
You're looking at. Whereas this is about 80 million years old because it's from Mongolia.
Yeah, so it's from this ankylosaur called Pinacosaurus, or is it Pinacosaurus?
Isn't it?
Palaeoneurology.
Yeah.
Dinosaurs.
Um,
Isn't them like jokes that it's called like the Pinocchio's?
I don't know.
I don't know.
But yeah, I mean, you like almost never find this structure
no.
fossilized. So
Well, because a lot of the time it's mostly cartilaginous.
Yeah.
It's only really in like birds that it starts ossifying.
yeah, it's really cool. So what is the larynx? What have they found here?
Well, it's part of the hyolaryngeal apparatus.
Right.
And I mean, I looked at some of the bits in it. So you've got the cricoid and
Yeah.
the artenoid process. But to be fair, it turns out that actually it's a very complicated structure and it's very hard
Yeah,
to get your head
I
around.
don't know what all of the names mean. It's kind of, I mean, yeah, as it's never found as fossils, it's not something we've really looked at
Yeah.
before. So
But
We're
to be
stepping
fair,
into proper paleobiology grounds here.
yeah,
but to be fair though, while didn't really know what all the bits were, like it was well described. Like when I was going through, I did understand like what they meant by the different bits.
that's good.
Yeah, one of the first things is it's actually preserved in life position.
So cool. So they've got the skull here. So there it is. It's looking underneath the skull, mandible, front of the upper,
It's
Pretty much
unfused 'cause it's
killer.
juvenile.
and then that's so that's it in there.
Wow, that is amazingly preserved.
Yeah, it's very cool. So what have they? I mean, the things that even in the title of the paper itself, but all the things. The main thing all the media sites are reporting on is that this means ankylosaurs could sing like birds. But I don't think it means
not-
exactly that. But
Paper
it's
doesn't say that. But
bird-like vocalization. It's like bird-like style. But not-
yeah. Like so a lot of what this paper does is going through and comparing it to modern day reptiles and birds.
yeah.
So like for example, the artenoids are fairly short in non-dinosaurian reptiles,
Yeah.
but they're quite long in dinosaurs, like birds.
Oh, yeah,
And,
so here we go. That's what this shows. The length there, is
Yes.
it? Yeah, standardized. Yeah.
and the cricoid width is actually really large in these animals, like in vocal turtles,
There we go.
birds, and geckos.
Yeah.
It's also like
quiet turtles. Sorry.
Yeah.
Just quiet turtles.
oh yeah,
That's fine.
yeah,
Vocal turtles and quiet turtles.
like the velociraptor.
The
noise.
velociraptor
Yeah.
noises.
Yeah. And yeah, there are some similarities with crocodilians as well. I think in the on the cricoid body.
Mm.
There
Well,
are
yeah,
similarities with turtles, which I wasn't expecting.
really up there. Like even higher than
Wow.
avians.
A point they do bring up is it is ossified, which is like birds. Birds. But then there is also like a small counterpoint of, well, these are ankylosaurs.
Yeah, everything's ossified.
Yeah.
Their eyelids are
But
ossified.
I think because it's unfused, this is a juvenile. It's probably
Yeah.
I don't think it's an ankylosaur thing. actual
Like
dinosaurian trait.
yeah.
Um,
But then would you not expect that to be found more often? Or probably not. They still just kind of too delicate. Yeah, I guess it's still an
Yeah,
unusual
it depends
thing
on
to
the
find.
fossil, because the problem is with these Ankylosaurs from Mongolia, the head is the most important thing. You
Yeah.
may have a near complete specimen, but like we saw in a few episodes ago where we talked about the damages that was it Zool had made on each other by
Yeah, and
smacking each other.
Prototype.
Yeah, they saw armor damages from another Ankylosaur. You find all these bodies, you can name you can name about 50 new groups of Ankylosaurs, but you would really need the skull. So
yeah, but I don't think it's entirely sure whether it is an ankylosaur thing or not. But apparently, they talked a little about this. I'm not sure how they worked out, but apparently, like the sort of ontogeny of it is similar to birds, like how it's not completely fused yet at its life stage.
Okay.
Really interesting.
Yeah.
So I guess that's another indicator that it's a bird style
Yeah.
communication. And apparently, so there's this bit I fully there are some of
love
it's
that
really to go
reconstruction,
over
it's
my
really
head,
nice.
but apparently there's this bit called the glottis, right? And it had these really large areas for muscle attachment. Now I do understand that, like rugose bits on the
Yeah.
bone, and apparently that is very bird-like.
Okay.
Being able to open this thing called the glottis easily.
Yeah, so from when I briefly looked over the paper to write about it in 7 Days of Science last week, and so they basically just say, well, they had a lot of like control so they could modify the sounds they're making like
Yes.
birds do, and then also isn't it that they can make like really loud and explosive calls?
Yeah, so they had like an avian style sort of
Yeah.
airflow regulations. So that's really good for modifying sound.
Yeah,
And yeah, so those crickles we mentioned earlier, which are really big, that allows them like to be like pretty loud and have explosive calls.
so cool.
Like
Those
birds.
the
So
comparisons.
yeah, and apparently, so this was quite interesting. They compared it to parrots and passerines in the fact that the larynx is actually kinetic.
Oh,
so it
cool.
might have actually been quite complex.
Well, it could have mimicked human speech.
Well,
Wow,
Just
imagine
walking
how
in the Cretaceous here. Hi, Alan.
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 well, that's the thing though. I mean, this is an ornithischian with bird style
you saying
communication.
Tyrannosaurus, not only was it smart enough to have
Oh my
culture and
gosh.
spears, they could also speak English.
Yeah.
That's where the culture
Crazy.
comes in.
Wow.
Yeah.
Yeah. I imagine finding a Tyrannosaur larynx though, that would be cool.
But no, it's very interesting. I think for the evolution of birds and dinosaurs in general as well, because it makes you think. Well, this could have been actually like an ancestral trait for Dinosauria.
Yeah.
But also,
I mean, that's sort of what's implied by the this-
no,
Yeah.
that is a quite nice dinosaur. I did like that.
Yeah.
Colourful.
Well, at the end of the day, it's going to be the sediment that's made that area of the fossil preserve so well. So I'm just trying to think of animals that have come from that area. Like, is it the Hauschka-raptors? Could you imagine finding another larynx in a Hauschka-raptor and seeing?
Yeah. I mean, you'd expect them if they're like that in ornithischians and birds, then you'd expect them to be similar as well, right?
Like
They're, like,
native
fractured.
nature actually having like Mandarin duck
although-
noises.
To be fair, this was originally misidentified. Like they thought it was just like a bit of it, or like.
Oh, okay.
But then they're like, oh, hang on, we've got the entire
Yeah. That's really cool.
apparatus here.
But they still recognize they still had it. So that's the
Yeah.
most important bit.
But
But,
also, like
yeah.
Hamza, yeah, you mentioned obviously the clubbing each other. So I was wondering, like, the implications sort of for Ankylosaur sort of what's the word, like socialization. Not like not talking like herd behavior, but like they might have had really complex like intraspecies behavior.
Yeah, like
like-
using calls and
Yeah.
if they're
Like,
displaying with their
especially in terms
clubs.
of like maybe territory or like
Yeah.
if they are.
It's
each
incredibly
other.
weird how in the last 2 years we've learned 2 years we've learned so much about Ankylosaurs.
Yeah, no, it
That
does.
they can dig, that
Yeah.
they fight each other with their clubs. Their clubs are not designed for defense so much; they're designed for species rivalry, you could say, or mating displays, or just like.
Yeah,
And then you've got this larynx
Yeah.
now,
So
which
they
is.
might have had some really complex behaviors.
yeah, you've
amongst
got a
each
good,
other.
good point there.
There
'cause
is an
it's-
idea that apparently Ankylosaurs. I know this is in Nodosaurs. They might be in Ankylosaurs as well. Ankylosaurs sometimes follow forest fires.
Oh yeah, because they've got like the seed or stomach contents.
Yes,
Wasn't
they
that
have
Borealopelta they looked?
I think so. They found burned ferns in their stomach
Yeah.
because they prefer to eat them. So after forest fires, they would be eating the vegetation.
And they portrayed that in Prehistoric Planet.
They are absolutely.
Did they? They showed that.
Yes, yeah,
Yeah.
they did.
They are just weird animals.
Yeah, no, it is kind of crazy because for a while, like traditionally, you kind of think of ankylosaurs as like just, I don't know.
Slow lumbering.
Yeah,
like,
dumb animals.
They exist and nothing's gonna.
Now,
Yeah,
go
I've
near.
There's
just
so much
I've just thought
complexity to
something.
them.
we've just had the larynx, and they're saying the complex structures. They may be able to have like parrot-esque type of like vocalization.
Just complex.
And what we need is Pinacosaurus.
And, yeah, I would
We
say.
need a endocast cranial scan to see if they have the factory
Probably done that,
bulbs
haven't they?
to actually receive good if they have good hearing.
Oh,
Oh.
yeah.
I don't know of any studies of like,
Ankylosaur Brains.
but they must have done that with
must
Pinacosaurus.
have
Surely
done
they've
it
got so
in
many fossils of
Borealopelta.
it.
We'll have to look at
Yeah,
They
I'll have a look
must
at
have
that.
done it. But what I'm saying
Could
is
be
like
interesting.
if they have that cranial endocast and they have very good hearing, then that would be amazing. That these complex structures could go long distances, or they have very
Yeah.
good hearing.
Well, can you imagine how scary it would be? Like, you've got an animal that could quite literally smash bone, and it's probably making the
Yeah,
same noises
creepy.
that bone would make when it smashes.
Course.
Like,
Yeah.
these really loud, like, crashes.
What I would find absolutely terrifying going into the Mongolian deserts during the Cretaceous is hearing this beautiful sound of an ankylosaur, going to approach it, and you see this monstrous club coming at you.
Yeah.
That would be
But-
horrifying.
Yeah, I think it's been a bit overblown, like the whole bird, like.
Yeah, because obviously birds have a completely unique like vocalization structure, which is the syrinx,
Yeah.
which has not been found in non-avian dinosaurs so
Well,
far.
also, songbirds are their own group,
Yeah,
so
yeah,
that's,
exactly.
that's
It's-
another
yeah.
thing.
What I would say is find the closest animal that has a similar larynx as that,
Yeah,
and
they look at-
just scale the sounds.
Mm.
Well, they look at neo naps because they're like
Neonaphs?
they're sort of like split off like not
here we
long
go.
after the Cretaceous.
Not basically everything that's not a paleognath,
Yeah.
So what,
So not-
ostriches.
excluding
no.
ostriches and such,
What is that?
excluding the ratites. Neognath is like, yeah, birds that aren't ostriches and relatives,
Hmm.
and
Weird
other ones in it,
things.
I think as well. Did we? Sorry, I just remember making a mental note of this as well. The plural of larynx is larynges or something. We didn't
yeah,
say
that makes
larynxes,
sense.
did
That's
we?
the same as phalanx.
Oh, yeah,
it's
that's what I was
phalanges. I'm
Yeah.
writing on my desk and it confuses me
Is it
so much.
It's something. It's
Must
not
be.
larynxes.
Yeah, it must be laryngeal.
Laryngeal. Yeah.
Gosh,
Anyway,
look how confusing that gecko is.
Wait.
on the
Far left.
Oh, okay.
Wow.
Yeah. Well, apparently they are quite vocal.
Hmm.
Oh, have you heard,
I
have you heard
mean, I didn't
gecko?
realize-
Geckos are quite loud things. They're
I
very
haven't-
good
I haven't
vocal
heard them.
things.
So who wants to do an impression of an ankylosaur?
Well, we need our legendary impressionist Eddie
Oh,
Bartlett.
for me. What? So it's a loud, explosive call.
Hmm.
Okay, let me have
And
a
kind of
let me
like a bird, but not like
Or
a
just
bird.
like.
Yeah, something like that. Did that pick up? You know what we have to add if it did. I know what they sounded like. I don't know if anyone actually noticed that in the last episode.
No,
I
only
saw-
one person
yeah, I
did.
saw
One
that.
person noticed
That
it.
made me. I could not stop laughing for 5 minutes after I added that in. Anyway, so is that pretty much all of it? I
Yeah,
mean,
no, it's obviously because it's a nature paper. It's quite short.
Yeah.
Yeah,
But
they have to
Nice
keep them
summary.
short,
Yeah, it
don't
was
they?
really interesting.
Well, what I can say from here is moving from the larynx, we can go straight to the brain.
Up a
Oh.
bit.
You want to go into that? Yeah, yeah. Okay, so do you want to take
Yeah,
this
this was
off
quite interesting.
for a second? So the next story we've got. Yeah. You got notes there.
Yeah,
I've
I've got
quite
my
a lot on here.
notes. I like to
Um,
write my notes out, but
I'll use Ben's.
This is like one of the bigger stories from last. When was this?
last
2 weeks ago?
2 weeks ago.
13th of February. Okay, yeah, you can put
Yeah,
it
2
back.
weeks ago, because yeah.
Do we have access? Yes, we do. Very nice. The Spinosaur Brains.
Yes.
So we went on about Tyrannosaur Brains for so long in the last episode, and so they were like, "Oh, let's give them some
And guess
Spinosaur
what?
Brains to talk about."
There's more than one author.
Oh yeah, that's helpful. A lot of big name paleontologists in this one.
Chris Barker.
Chris
Mm.
Barker and Nish worked on the Stratosuchops Raparovinator
Yeah.
papers.
So
and I think Neil Gosling did as well.
I think so. And I know Larry Whitmer is on there. He's is he which Ohio? Yeah, it is. Really great comparative anatomist. Has a really good YouTube channel. I think I've mentioned it on here before.
Yeah, you have. Yes, I remember you mentioning.
Whitmer Lab. Really interesting. Just does a lot of dissections and looking at skeletons of modern animals and prehistoric ones. So.
Yes. So going into the this study of Spinosaurid brains or Spinosauridae brains.
Specifically baryonychine Spinosaurus.
So they looked at baryonyx and Ceratopsicops. I was going to say baryonyx walkeri, but I can't remember Ceratopsicops' Inferidus?
Inferidus. Yeah.
Inferidus. Yeah, so baryonyx walkeri and Ceratopsicops inferidus. You may be wondering why there is no Ceratopsicops millinare. No, sorry, Reparovinator millinare.
The other one,
I think there was the endocast is crushed.
Right.
It's not as preserved as Ceratopsicops is.
Yeah, I know they say that they made so both the baryonyx and the Ceratopsicops endocasts, they were made from the fragments were in like 3 blocks. Both of them are in 3 blocks, but yeah, obviously there's enough to reconstruct them pretty accurately. So yeah, I think one of the really interesting things about this is looking at Spinosaur evolution. Obviously, these animals are aquatic. How aquatic they are is obviously contentious and debated and whatever. But even in
Ibrahim saying that Baryonyx has very pachystotic bone.
Yeah, really dense bone. Was a good swimmer.
Similar to Spinosaurus, not as thick as Spinosaurus.
Yeah,
but,
the Spinosaurs as a whole were definitely tending towards a more aquatic lifestyle. So would you expect the brains to have some modification like towards that sort of lifestyle? You might think they would, but then the main conclusions of this is that actually they have very typical brains for a generic theropod.
Yeah, which is interesting.
What I found really interesting is they brought up Irritator. They brought up Irritator's endocast. Now we have to remember one thing. Irritator is a Spinosaurine.
Yeah.
Baryonyx and Ceratopsicops, as Ben mentioned, are baryonychines.
Yeah.
So they are
there's probably a phylogeny in
I don't think there is in this paper. No.
Let's quickly bring up.
Yeah, so then they're quite far apart in the phylogeny.
Oh.
But one thing I found was that Irritator has an exceptional / typical hearing capabilities. Inferred rapid and controlled pitch down movement of the head. Unexceptional. Sorry. Probably aiding in the predation of small and agile prey. Now, one thing that I really like about that, when they mention agile prey, in Angylosaur, the pterosaur, they have an irritator tooth lodged in the neck.
Oh, yeah.
So, that backs your idea, but as looking on the screen...
Yeah, so there's Spinosauridae, the whole family, splits into baryonychines and Spinosaurians. There's Baryonyx, Reparovinator, Ceratopsicops. Irritator down here is a Spinosaurian, and Spinosaurus itself.
So the baryonychines are mainly situated around Europe, except Suchomimus. Suchomimus is the odd one out, and going into Niger. So you could say the baryonychines are Laurasian. They're heavily situated around Laurasia. Then you've got the Gondwanan Spinosaurians.
Yeah.
But I forgot to mention this. I remember the original paper was Ceratopsicops and Reparovinator had broken them into another group, Ceratopsicops.
So there's the other division.
Yeah, but they are very confusing animals.
Yeah.
I was going to mention that the how do you get to understand and how do you get to the point of actually seeing what a brain looks like? Well, they CT scan the endocasts of the animals.
They used both the holotypes. It's the baryonyx holotype and the
Ceratopsicops holotype, yes. Because they're the only two that have the best complete cranial elements, other than...
There's the baryonyx one here.
Yes, and then...
I don't know where the other
Ceratopsicops is further above, yeah.
Okay, that's...
Oh, is that baryonyx or was that Ceratopsicops?
That was both of them, I think. There we go. That's Ceratopsicops.
But one thing I want to mention is how they actually worked it out. I think it might have been similar to the Tyrannosaur paper.
What, did they make soup?
There is some EQ stuff.
Okay.
Or reptile encephalization quotient.
Encephalization
Yeah.
which is REQ.
Yeah.
Yeah. How they did it, it was given a measurement relative to the brain size and gross cognitive capacities. No, which you can actually work out in reptiles. Yeah, so apparently they found that they had typical Mesozoic theropod-like
so interesting
olfactory sense of smell. And
so
similar to Allosaurus and T-Rex.
Their smell, well, not similar to T-Rex.
Non-Silurian, sorry.
Right, yeah. So T-Rex has, T-Rex has exceptional sense of smell.
Yeah,
based on the size of its olfactory bulbs, but these did not. They were nowhere near that.
They were basically just...
Yeah,
so
which is interesting.
You could call them just typical theropods, which is very weird what they're doing.
What sort of features would you actually be able to see and then endocast, and what would you actually be looking for sort of aquatic adaptations in the brain?
You would want good eyesight.
Yeah, well, one of
the
interesting things. So you mentioned Irritator earlier. So Irritator's brain was looked at in a 2020 paper, and it's a Spinosaurine. So in this paper, they're looking at Ceratosuchops and their baryonyx, and they're comparing that to the results of the Irritator paper. And they find, so it's called the floccular lobe.
Oh, yeah.
There's a relatively large floccular lobe in Irritator, and so they take that to mean that there's good gaze stabilization. So it's, regulating gaze stabilization.
Oh, is that what
where you compensate for head rotation by moving the eyes and helping to just track moving objects across the field of view.
That is incredible.
So, Irritator seems, if you can correlate that with the size of the floccular lobe, to be good at that. And then, looking at baryonyx. Oh, they say, looking at baryonyx specifically, comparing that to Irritator, it could have had a similar good gaze stabilization adaptation, which, could be good for looking at fish in the water, like tracking it, waiting, and
or potentially just even smaller prey.
Yeah, I mean, baryonyx is fairly generalist. We know that.
Yeah, it's the biggest Wessex Formation, Weldon group theropod. They found baryonyx, they found Bonodontian bones in the stomach. So
isn't that pterosaur? You keep mentioning pterosaur predation.
Yeah, so Irritator has.
Is it not baryonyx as well?
No, baryonyx is baryonyx is the Lepidodes scales and the Ankylosaurus.
Yeah,
and then Irritator is the.
It's just Spinosaurs.
The Spinosaurs, but it doesn't mean that the baryonychines were not going after the pterosaurs. Well, good luck, but
well, we don't know what soft tissue
characteristics
they have.
We have to also remember that the Spinosauridae have amazing sensory pittings at the front.
Yeah, so that's something they investigated, and they say there's not... I'll find the bit. Yeah, here it is. So, they need to study that more, basically, is what they say. So, tactile sensation of the face and jaws of vertebrates is detected by something called the trigeminal nerve, which, runs through the maxilla and stuff. But there's little evidence of an emphasized trigeminal nerve system in Spinosaurs based on what we've got so far. And that's apparently consistent with previous observations. So what they need to do, they say in the paper, this is direct quotations, further work, perhaps focusing on the branching pattern of canals within the dentary, which may provide the clearest signal for facial tactile sensation, for instance, is clearly needed before rostral neurovascular specializations can be inferred for the clade. But it seems like they probably are using them, but there's no direct evidence from the nervous system, so we need to look at that.
We have the idea, but we don't have the answer to back up the idea. What we need to not do is not look at Spinosaurus. Because Spinosaurus is too derived in comparison to these guys. And the problem is, I don't think one of them has a lower dentary, so I had a Suchops or a Parvonator. One of them has a fraction of a dentary and doesn't have the front.
Skimming.
So
it must be it.
But reverse, because we're going the wrong way.
Yeah.
Well, I like how I just quickly, kind of off topic, I noticed how one of the citations in discussing the trigeminal nerve was Dr. Julian Benoit, who obviously invited me to South Africa, so shout out to Julian. He's done a lot of work on trigeminal nerves and things like that. Very interested in that sort of thing. So that was really cool to see him cited in there.
But one thing we found really interesting was about the low frequency.
Yeah.
That was quite surprising, actually.
I'm just trying to find nice. Do they just have the brain scans in it?
Yeah, it's not a
Oh,
lot.
that it wasn't as specialized for.
No,
low frequency.
They're specialized for low frequency. Not really anything further beyond that.
I just want to find. I know there's some nice paleo art that came out with this.
Yeah, well,
Oh, is it the one fishing?
There we go. Yeah, it's really cool.
Yeah, that one. Yeah. This artist, oh my gosh, is incredible.
Yeah, I think it's the same one who did all the.
They're the ones that did the Ceratocopter
Okay.
Reparvinator one. I swear they have to be the ones because they look so similar.
By Anthony Hutchings.
Oh, is it? I think it is now.
Hmm?
The Ceratocopter Reparvinator.
I really like it.
cool.
It's so nice anyway.
So cool.
Fine scale detail.
Yeah, it's really nice. Yeah.
It looks so much like a Komodo dragon, just with the scales. But it's so nice. It shows that like paleo art is just going further.
Yeah, it's really incredible.
But I guess we gotta be a bit careful with like not extrapolating this to all Spinosaurs, because obviously this is a separate branch that is removed from.
But yeah, I mean,
Spinosaurs.
the comparisons to Irritator are clever as well, because that is, I mean, it's both lineages.
Exactly. Yeah.
But yeah, Spinosaurus itself is a very different animal anyway. One of the other things, so you're talking briefly about the vision capabilities. They say that there's imperceptible optic lobes preserved in both of these endocasts, so it's not that useful. They can't say much about how good their vision was, basically. But they say it's beyond the scope of this study, but they note that Ceratocopter, at least, has orbits that are very forward-facing relative to other theropods. So does that mean it's got a higher degree of stereoscopic vision,
Yeah.
where like humans do, where you can get 3D like depth perception because our eyes are
Oh, is that
overlapping.
like with the Tyrannosaurs, like their vision can...
Yeah, the overlap.
Yeah.
Yeah, they
vision.
overlap, yeah.
But interestingly, they say we note that stereopsis can evolve in animals with laterally facing orbits, and that it may not necessarily be present in animals with binocular overlap. So it can still happen when they're facing, the
Yeah.
orbits are facing outwards, but
Seems to be a
interesting.
decent indicator.
yeah. So yeah, I mean, you'd expect that for something actively hunting fish, I guess. Pretty interesting. And then yeah, you mentioned the hearing capabilities, so they probably had quite low frequency hearing.
So, to understand what you mean by low frequency hearing, so what do you mean by it in the grand scheme? Like, so
just very low. I don't know.
So it would do something similar like Crocs are doing with their low frequency.
Oh, well, I've had
Yeah.
bellowing.
Yeah, so like that's like a mating call, like a scare tactic.
But then they say it's not as specialized for the reception of low frequency sounds as those of Tyrannosaurids, but they would still have been detecting low frequency sounds.
If they're generally the larger the animal, the lower
Yeah,
frequencies.
exactly. Just a big animal is going to be making deeper noises in general.
What I would
so-
love to see as a paleo art, and I might have a little gander at this, is a baryonychine in the water like a croc, and just bubbles coming out from
That'd be cool.
from the gular region, just like that would be really cool. All we need is the larynx of a Spinosaur now.
Oh,
Yeah.
good luck.
Yeah.
Yeah, briefly, the reptile someone said it should be. Were we saying
Yeah, no, someone said
encephalization?
we
It
said
should
it
be
wrong.
Tricky
encephalization.
because when I first went off for uni, I always thought it
Yeah.
was like like
I always called them,
cephalopods.
yeah, cephalopods.
then-
I always said that.
Yeah, and then like got to uni, it's like no, it's kef.
Cephalopods. Yeah, because I know in Greek, I'm assuming it's Greek that this is derived from, and Latin. I did Latin. It's like a hard C when you say like, so it should be like triceratops, but that sounds so stupid.
Triceratops.
I'm gonna keep saying triceratops. Encephalization or encephalization.
We know what we mean. Yeah.
Yeah.
We're still
Anyway.
ignoring the comment.
Reptile encephalization quotients. Basically, baryonychines didn't deviate substantially in terms of the cognitive capacity and behavioral sophistication relative to other basal theropods. So it was, yeah, nothing unusual there, about as smart as other whatever encephalization quotients mean,
I mean, they're probably not the best indicator, but at least it's consistently used. So we've got
Yeah.
other dinosaurs.
They're in the
compared
same
against.
realm as
We're gonna
other
see.
basal theropods.
They got long arms. They can pick up spears. Just
Yeah.
walk around.
It'd be good for fishing.
Judging distances with a binocular vision. and
With a
everything.
fishing
rod.
Yeah. That is what they were specialized for.
Yeah.
There's a
what's
really
this?
nice paleo art though.
There's no tangible evidence for adaptations to semi-aquatic ecologies in the baryonychine endocrania, suggesting this is a quote. Yeah, basically saying the sensory systems and the
They're
neural
not developed
systems.
for swimming yet.
But they seem to be pre-adapted almost, like they already had what was needed to then become
Although-
semi-aquatic.
Isn't there like a lot of Megalosauridae already like proposed to have had like some sort
Yeah.
of like
But that's the interesting part. Then why are we having really thick bone in these baryonychines? That's the
Well, no, I
odd
mean
bit.
they definitely were semi-aquatic to an extent, but it's like they don't have any like neural specializations that would necessarily help them. It's not like they're not already very clearly
Like
specialized
when
for
you-
that.
when you
They just
put,
have
like,
the default stuff.
But when you put like a child in a pond, or like
They already
a
know
swimming
what to
pool,
do.
Yeah, they're
Yeah.
trying to work it out.
I guess like theropods were already well suited
Yeah.
for that. That just happened to be how they were.
They came
so-
out the swampy swamp with
Mm.
a Campostega.
but no, I meant like a lot of megalosaurs are already like some evidence for potential fish eating.
What's it? Ceratosaurus?
Yeah.
I heard that a long time ago. I think
Well, that's not.
Oh,
Megalosaur-
yeah, yeah,
Well, that's
yeah.
not Megalosaurus.
no,
yeah,
no.
yeah,
but
there's
yeah,
the
there's
idea
other
it can
theropods.
swim. Yeah.
Some people, I'm
Well, a lot
I'm
of
not sure if it
animals
was back
swim.
then.
Come on, how's if a giraffe can swim?
No, not this again.
T-Rex could swim. Prehistoric Planet proved it.
But Spinosaurus could not.
No, that's too far.
So I was going to mention, if we're finished with the Spinosaurs.
I have one more thing. To
Okay, one more thing.
Oh,
okay,
I
so-
had a really cool transition.
Yeah,
really
yeah.
cool transition.
I was just going to briefly say, because, Darren Osh's on this paper actually told me about this a while before it was published, and I liked how he kind of explained what they'd found to me, is that it's like, I think he said this in interviews in other places. He basically says like the hardware is becoming specialized, but the software inside is like still the same. It's like the skull and everything is becoming aquatically specialized, but then the brains are
The brain's
The
a
same,
bit,
so-
it's slowing on that update.
Yeah.
The Windows update.
Brain was thinking, I want to swim.
yeah,
Let's make the body swim.
pretty much. It's cool. Yeah.
Well, from swimming, let's go to the ancient seas, the Jurassic Book.
Want to switch?
Ancient sea
What to do at
reptiles.
the end?
You want to do the end?
Do you want to do it at the
Yeah.
end? Damn.
Okay.
Oh, he
switch.
said it. Honestly, yeah.
Shall we
Or-
go
or-
to the special interview, special guest star? We just did it.
Oh,
we just did it.
Yeah.
Oh,
Yeah.
I'm so
So
tired.
basically, yes. Yeah. I mentioned this again later, but today is when we're recording this is the 1st of March. Yesterday, 28th of April, 20th of February.
April.
I've skipped a month. 20th of February would have been 5 years exactly since the very first episode of 7 Days of Science, 28th of February 2018. So to discuss that, we brought on Doug, and he just had a quick interview with us, kind of reminiscing about 7 Days of Science, talking about how it's changed and everything, and the impact it's sort of had on people and us.
This tears hot. Okay, I've started recording,
let's
so we
just
can go
roll
whenever.
that. Here's Doug. Well, welcome to the show, everyone. This is Doug A. James of 7 Days of Science fame, and it has been 5 years. So we're recording this on the 1st of March, so yesterday would have been exactly 5 years, 20th of February 2018, since we started 7 Days of Science. It's a fan favorite, I think we can say. So yeah, I thought it'd just be interesting to kind of discuss the background to it and what you remember about creating it, and kind of how it's influenced. I don't know, that sounds a bit pretentious, but like how people have responded to it over the years and everything. Because I have, like, being at university now, knowing other paleontologists, they have said that it's, it's been a way for them to keep up to date with paleontology news and stuff, which is great to hear. That was always the aim. So
Yeah, that's so cool.
I remember it was sort of you wanted to kind of have like a series on the channel. So we weren't already doing Animal of the Week, were we? We just had like My Sunday videos.
No,
And then we thought it'd be good
we
to
just have
have
the normal Sunday videos. Yeah.
yeah, we thought it'd be useful to have like just like a weekly series to do, and then somehow we never missed a week for 5 years, which is quite cool to say.
I can't believe there's occasionally been like a 6 days of science or
Yeah.
an 8 days of science, but
I think that was
we have
during,
done a video every single week.
yeah. Was it
Um,
during our A-level exams? I seem to remember there was like like an 8 days and a 6 days, I think.
Yeah, I
hasn't-
did a
hasn't
couple
been
recently
often.
where I was editing really, really late. And
Yeah.
it, went past midnight, so I put 8 days of science. But yeah, during our A-levels, I think we did it on a Thursday or a Tuesday a couple of times because
Yeah,
we had
we
our
can't-
A-level exams.
That was
It's still impressive you put them out anyway.
yeah. It's
Yeah, so I remember I wanted to do a series that kind of was for the subscribers rather than the Sunday videos that was obviously for the subscribers but also bringing a lot of other people in. A series that Benji Thomas viewers would recognise and hopefully grow to love. And I remember at the time I was always like looking through the news, so I always knew all these random news stories all the time. So I thought, well, just let's really try and like properly look through the science news and get the coolest stories and make a series about that.
yeah.
And that's what we've done for 5 years. I remember in our first year of university, we had the 3-year anniversary, and we went, "Oh, 3 years! That's incredible! That's so long! I can't believe we've done it." And it feels like that was 12 seconds ago, and here we are,
it's
5
very
years.
strange. Yeah, and it's as I've said in the episode, which will be up later today when I go back and edit that. It's been really cool to see like the science of paleontology progress over those 5 years. Like, there's been so many incredible discoveries. The one that for some reason always comes to mind is like the number of studies on Denisovans that have happened in that time. I know we've done quite a few episodes on them, and there's like so much of our knowledge has like improved about Denisovans specifically in the time we've been doing it. So yeah, we sort of cut out there, but basically there's a permanent record online of our hair growth over lockdown and the various phases we went through. So that's cool.
I remember when we started, I thought, it would be funny if, like, I kind of just became this dishevelled character over the
and the eye
next few
patch,
weeks,
of course.
And then eventually the eye patch came into that, but we only thought it would be, like, I was like, okay, so I'll do this, and then, next week I'll do this, next week I'll do this, next week I'll do this, and then, 4 or 5 weeks' time, I'll do this, and by then it will all be over anyway. That's I think the thing that reminds me clearest about how short we all thought the lockdown was going to be.
Yeah, we didn't know what to expect at first.
Yeah, because we thought it was just going to be like a month or two, and so I ran out of things to be dishevelled, and then I ended up putting an eye patch on for like 3 months.
Yeah, people were so confused about that. Like, they thought you actually had lost an eye, and then I remember you came over. Was it like one of the pauses in the lockdown? You came over and we recorded like the how you got your eye back.
How I got my eye. I was like, I can't continue with this eye patch. I've got to have an eye again.
Yeah.
And now we've got this entire lore of 7 Days of Science, which I filmed some extra stuff for this week with a couple of friends who are actors. So that's fun.
Yeah.
There's so many dumb plans we can get into now. I'm really excited.
And we spent like a whole day filming with Joe. That scene, like an after credits scene and everything. Yeah, we put way too much effort into some of these episodes.
Way too much. For how many people watched it and went, why am I watching this?
Yeah.
But I'm making, as you know, Ben, I'm making a short film at the moment, which should be really exciting because when we get to the end of it, I'll have a lot more kind of experience and knowledge on how filming works, and it means we can do some really exciting stuff with Benji Thomas.
Nice.
But also because through that and through stuff at uni, I've met and become friends with loads and loads of really incredible actors. So in order to help train them up in filming and being filmed on camera, I brought them all over last week or the week before, and I think we filmed like 3-4 intros.
Nice.
And a couple of things for outros as well. So the first one of those was last week, and there'll be another one this week, which was the most complex one to film-ish. And that was the one that I actually thought of. All the others we just thought of on the spot. But this will come out after 7 Days of Science, but the prawn thing was was fun to do. It was dumb and fun, and we all enjoyed it. So
Yeah, what was the one
together and like, do you want to do an intro? Yeah, sure.
What was your favourite one, you said?
I like the one where you were running around like Southampton Uni, just like lost.
Oh, when we interviewed Naish.
Yeah.
Yeah, that was a good one. Like
Was this
intercutting it
when
when
I'm
you're getting
walking around
lost.
campus?
Yeah.
Yeah, that
it
was
just
really
sort
fun
of
to
cut out
film.
that.
I just got my my friend to just film me walking around some of the kind of more like foresty bits or less bricky bits of campus, looking lost for like a couple of hours. Everyone must have been so confused to see somebody pointing at a camera at a man in a blue suit walking around going like, what the hell?
That was a classic.
Plans for do that for Eddie in Dorset.
Oh, we should have done that.
Of
Yeah.
Eddie looking distraught about
I mean,
the
there was-
Tyrannosaurs being as smart as a
Yeah.
baboon.
There was that whole like bit where you guys were just like, I don't know where he is.
We did lose you for a bit.
We
yeah.
lost you for ages.
Yeah, I was thinking, isn't that? I think the interview with Naish, the Spinosaur one. I think that is the most viewed 7 Days of Science now. I think. Or no.
Is it?
It's the Nodosaur hard of hearing one. For some reason, that's got quite a few 100,000 views.
Oh, was that the one where
It's really short.
like
It's like the shortest episode.
Is that the one where the intro is and the outro is just me doing something with like fish and chips?
Possibly. It's like a 2-minute
Yeah,
video.
I remember
And it's on
because
most
I had nowhere to live at the time, so I just went for a week on like a road trip to like
Yeah.
I went to like Folkestone, then somewhere up a little bit north of that, and then to London, then to the Lake District and back. And for that week, I ran out of mobile data as well.
I do remember now.
During that, so I panickedly like sent you these just dumb things to do for an intro and outro, and that's become the most viewed 7 Days of Science.
Yeah, I think it might have been one of those. I remember that. It's great how many kind of mini story arcs there are with the intros. And then I was looking at the comments on the very first episode earlier today, and even back then there were people commenting about how the intro cuts off. Was that initially an editing error or what? I don't remember how that started.
It was. I can't remember what it was. It was like I think I wanted to have a proper intro.
Oh,
No, okay. So the
cut yourself
intro we
off.
originally had was like a placeholder, but we didn't make a proper one. We didn't really make a proper one until we got one made for us, like back for the 100th episode. And so the joke was originally, okay, guys, sorry, I haven't got an intro yet. We're just going to have to go straight into the video. And then I was cut off by a simple intro that I made. And that just kept on happening. And it's been 5 years of most, like 80 to 90% or more of all of the intros being cut off. And still we get comments saying, guys, you really need to fix your editing, like the intro keeps on being cut off. 5 years.
I think we
And for
decided
the
to
first
keep it
100
going.
episodes, it was every single one.
Yeah, we decided to keep it going because we saw comments of people being confused by it, and we just thought.
When was
it'd
the
be funny.
intro introduced? Was it like in the very first few episodes, or?
I don't know. We had. What was the first? Oh yeah, you made like the first intro, and then it was redone for us, like after the 100th episode. I think.
Yeah, it was the 100th episode we had the new intro. It was. I think one of the most interesting things in doing YouTube in general has been the comments and seeing what people comment and seeing.
Oh yeah, yeah.
like,
These
the
guys
distance
have
in watch.
started to learn that. They're reading
Yes.
every comment on these videos.
What I
and
love is no one can get my name right, and I just do not understand it. No one can get it right. Hamid, Temza.
Yeah, it's always fun.
I think the most interesting comments are always the ones that talk about how we film videos or how we make videos. And it makes me realise how little I know about how other people's processes are. Because people always assume we have this like massive team behind us. Whereas obviously we've got BoneHeads now, and we've got, Ollie and Matt, and Joe helps out occasionally. But most of the time, and for 7 Days of Science, it's just us two.
Yeah, pretty
doing
much, except for
all
the
of
ones
it.
where Ollie helped us when we were in South Africa. It's always just been us two for 7 Days of Science. So, yeah, I mean, you've been helping find news recently.
Yeah.
You always know where to look for things. So,
Cultivated my news feed
Yeah.
to always get it.
that's been
I'm
very
trying
helpful.
to remember. Have I helped you on 7 Days of Science paleo art?
Oh yeah, of course, you've done paleo art.
I
for
don't
us.
remember. The first paleo art I did for you
Yeah.
was a sauropod
Yeah,
video,
that's cool.
but I can't remember what the paleo art first
It
one I
was-
did for you was.
For 7 Days of Science.
7 Days. Was it a Spinosaur?
Probably. Was it not the new Spinosaurs? Did you do it? No, I don't think
No,
you
was
did
it the Spinosaur swimming?
It would have been
Might
like
have been.
near the beginning of second year.
I don't remember. I've done so many drawings for Ben, my mind's gone blank.
I think, yeah, he did like a few last minute ones when there was a new study, and we were like, oh, yeah, it'd be cool. You could do some art for that. You've definitely done Spinosaurs and
Theropods.
other
I did
things.
mammals. That's coming.
Eventually.
Fairly
Yeah,
soon.
we'll do that at some point.
And isn't there a couple for South Africa?
Oh yes. Oh my gosh.
Yeah,
that
yeah.
took me
I remember seeing those.
weeks to do.
Yeah, those are really good. Been using those. But yeah, so yeah, since starting actually being able to go into uni, so it was the start of second year when I could actually go in. It wasn't all just online, and like actually get to meet people. Like I met you guys, yeah, met everyone in the year, and there were, I mean, it was you and Jack as well. Also said like I'd been watching 7 Days of Science to like keep up with the news, like paleontology news, and how he found it really helpful. So that was really good to hear, because that's the aim of it, and it's nice that people use it for that. So that was
I got
mission
introduced
accomplished.
to you via the trip, didn't I?
Yeah, the first Dorset trip.
Yeah, first
Yeah.
Dorset trip we had.
Yeah. You didn't know who I was.
No.
I've
do
never
know-
had anyone come up to me and recognise me. I thought that had happened once, and it was someone in my uni halls in first year, and I knew like, am I going to be living next to someone who knows who I am on YouTube?
Yeah.
But I have had a couple of friends who have seen a video of ours. I remember one of my really close friends had, when I told her about my YouTube, she had a look at Benji Thomas and Doug A. James, and she had seen the snake video on Doug A. James and hadn't realised it was me, and was like what the hell? And like, threw her phone at me in a panic. And I also have a friend who does marine
funny.
biology, who looked up Benji Thomas and saw she'd seen loads of the videos. And was like, okay, this is weird.
Yeah, I was
So
gonna
that's
mention one of
always
my
fun
favourite.
and cool.
I was going to mention one of my
Puts it
favourite
into
wholesome
perspective,
moments
I think.
was in Oxford, when you
Oh,
got
yeah.
we got recognised by a fan
Yeah,
who helped.
someone recognised me on the street in Oxford. That was the first time it happened, like outside of uni.
Academics.
Yeah, and then obviously at TazuCon, people were familiar with the channel, so there were a few people who knew me there. But that's kind of to be expected when there's a lot of people in the paleontology circle. But it's still really cool. It was really nice meeting everyone. And there was actually another time recently, someone in Portsmouth, just on the somewhere. We went somewhere basically, and they were like, "Oh, do you have a YouTube channel? You look familiar." And I was like, "Yeah." It's like, "What's it called?" It's Benji Thomas. Oh yeah, I think I'm subscribed to you. And they actually left a comment on a recent 7 Days of Science, so shout out to them. It's really nice to meet you. That was really cool.
Pub as well, didn't I?
Yeah, you did. Yeah, we were
Yeah.
leaving the pub, and someone was like,
Yeah.
"I like your podcast."
Yeah, don't you
something.
work with Ben?
Yeah. But I mean, Portsmouth is kind of filled with paleontology students, so I think that's
Relative.
Doesn't count.
yeah. But it's still really nice that people recognise it, and
What I love is that the
Um,
professors are starting to recognise 7 Days of Science, and
Are
who
they?
want to help out. Yeah, like we got we got
Dave,
Professor
of
Dave
course.
Martell,
Yeah, yeah. We
who
had the
really wants to help out with getting Ben out there. And
yeah. I mean, we got the interview with him and everything.
Roy as well. Niz, we got
Yeah.
Dr. Nizar.
It's really built up a bit of a sort of cult following, hasn't it? Like,
I like to think so.
yeah, it's
That's
good.
Yeah, it's good that it can help people, and we'll definitely try to get more interviews with paleontologists in the future.
Yeah.
It's always that's like the thing I enjoy most about doing news videos, especially. It's just it's sometimes difficult to get them done at short notice when it's like every Wednesday you have to do it, but it is cool when we can manage it.
Oh,
so.
and you got this whole sod's law of papers always seem to come out on
Oh,
Thursday.
you beat me to it. I was just about to say my favourite thing about 7 Days of Science is some of the biggest papers always come out a day
Yeah.
after you posting.
It's
And
like
I find it so funny.
I think it was last week or the week before, especially. I was like literally rendering my 7 Days of Science segment.
that when the
as a-
Ankylosaur paper came out.
Yeah, when the Ankylosaur paper came out, which it must have been 2 weeks ago. Like as I was rendering it, there was like this huge new paper about Ankylosaur sounds and how they.
When it's all the comments like,
The
where's me?
amount of-
Yeah.
Dinosaur paper.
The amount of massive
Oh.
bits of news that have come out on a Thursday, it's just
Yeah, it's a joke. They do it
every
deliberately.
time. Yeah, they
Every
do,
paleontologist
they do.
must be a fan of 7 Days of Science, and there's some big conspiracy. That's what it is. Yeah. But yeah, here's to 5 more years of
Yeah.
doing it, hopefully, and
5 more years,
continuing
definitely.
to grow, more interviews and stuff. So yeah, thank you for calling in. Hopefully see you
Thank
in
you for having
person
me.
soon.
Yeah, I'll see you soon. And
Yeah.
Yeah,
So-
sweet.
I hope everyone has enjoyed 5 years of 7 Days of Science half as much as we
Very
have.
good.
So
It has
been
been
great.
great. 5 years, never missing a week.
Gosh, that's just still a surprise to me.
No, it's cool.
Christ.
Yeah.
Yeah.
Okay. Thank you.
Doug.
Thank you, Doug.
Okay, I really hope you enjoyed that quick interview with Doug. It was nice to see him again and kind of talk about all of the impacts of 7 Days of Science and on our lives and things. So yeah, we'll just continue with the news, I think. Up next, so if you want to switch to this, we have the first monotreme from the late Cretaceous of South America. So I very briefly covered this in 7 Days of Science, but not in too much detail. So do you want to tell us about what they found?
There's another very cool, but that's because it's it's a pretty early form of monotreme. Monotremes being echidnas and platypus.
Yeah.
And this one's called Patagorhynchus.
I like that name.
It's a nice name.
Yeah.
Patagorhynchus.
Gorilla formation of the early Maastrichtian. So that's late Cretaceous. Now, it's actually a bit underwhelming, but
that's all they have
is a tooth. Now, don't get disheartened because actually, when it comes to mammals,
that's the most important bit.
So because mammals have heterodont teeth, they're really different. They're really specialized. So you can actually learn a lot from them. Like in our mammal lectures, a lot of stuff is just based off a molar, but you can tell a lot because they're specialized for a certain way of eating. They have certain adaptations, and this is called dilambdodont, which is apparently characteristic of monotremes, but it has its own unique lophid and cusp structures, which make it its own genus. Apart from existing, some we haven't found monotremes at this time before.
This is the one they found that's comparing it to other ones. Yeah, you can tell it's a monotreme from just the.
It's actually very interesting though, because while I did say like mammal teeth vary a lot, they do note that actually these teeth are pretty similar to Monotrematum from the Paleocene of Patagonia and Obdurodon from the Oligocene of Australia.
That's Obdurodon and Monotrematum? Yeah, these ones. Yeah.
Which they note is like, well, hang on, that's very conservative in terms of tooth morphology because the Oligocene is a lot later. But that's also why, like, if you look up some of the art for this paper, they have it as a platypus.
Yeah, actually, it was really nice. I like.
Yeah, because
like
Obdurodon, we have a pretty decent skeleton for that is very platypus.
There it is. It's so cute.
Oh, I do remember this. Yeah. Just like the
I wondered why they had it like a platypus, but it's because its teeth is very similar to Obdurodon.
It's not the oldest monotreme fossil we have. I think the oldest is still Theropodon from Australia.
But that's the thing. This is outside Australia.
Yes, that's really cool. They've already
where are
spread.
they coming from?
So, because that's the thing. Before this, it was assumed that they had a single radiation outside of Australia, probably in the late Cretaceous or early Paleocene. But this is already like established in the early Maastrichtian. So they must have like spread much earlier than we thought.
Yeah, it is really cool.
Look at the closest,
Patagonia.
biggest land masses near Australia. Patagonia.
I mean, it's all still. No, it wouldn't have been Gondwana. I mean, they would have spread when it was still Gondwana, presumably.
Still call them like Laurasian Gondwana, even in Cretaceous, don't we?
But I mean, by late Cretaceous, they'd split.
But then in the late Cretaceous was Australia off Antarctica.
It was attached for a while. I think by the late Cretaceous it had detached. Not entirely sure, but at least in the early Cretaceous, it was still attached but splitting. Fairly certain.
Indicative in sort of terms of how much they radiate, because obviously monotremes used to be a lot more widespread than they are today. Also, monotremes today don't actually have teeth, but this does. I mean, a lot of older monotremes. See that one.
Platypus with teeth.
Yeah, they have like these keratinous like bulbs or sheaths or
we looked at some
they look like
recently.
teeth, but they're not.
It's so strange.
Really weird. And then echidna skulls, you can't make them up. They are
weird.
so
bizarre. We're gonna have to show some.
Yeah.
They're literally they look like just one bone.
You know what they look a bit like? The plague doctor masks.
They look like a spoon.
Look at these. Look, on the platypus skull, of course, as well.
Yeah, it's just
there you go.
Bizarre. Oh, is this wrong? It's the feet.
Oh yeah, the feet. Okay, yeah.
Feet should be the other way around.
Yeah, echidna feet. They're actually backwards.
Look at that thing.
That's not an echidna.
Real animal. Dunkleosteus, long-nosed echidna.
No, I mean the other image.
Look at that.
Yeah.
Where's? Oh, here we go. That's showing the correct mount.
Yeah.
And this as well. So you can see, yeah, the back feet are completely
It helps with
reversed.
digging.
Like,
Yeah.
honestly, when scientists first discovered this, they're like, no, surely, like, someone's mounted this wrong. Put the feet
Yeah.
back the right way. But that is right.
They are some of
it's
the weirdest
crazy.
animals. And then,
I think platypus they go out slightly, but they're not nowhere to the same degree as a kid.
I love platypus. Look at that.
They look like the.
Oh, hang on. Yeah, you can see the
Is it
Sorry.
this one?
No.
Go back. Yeah, there you
That-
go.
Oh yeah, yeah.
Yeah, so
So cool.
those look like teeth, but they are not. Yeah. Anyway, a bit of a side note. Also, they do mention that so this is actually at paleo altitude. Latitude of 60, which is pretty similar to Southern Australia. And so they're saying, oh, you know, this helps contribute to the idea that has been growing of monotremes evolving under like humid but cool, densely forested areas of Gondwana.
Yeah.
And
Cool.
yeah, apparently they just suggest that characteristics like a low metabolism and stuff are
Oh, that's
polar environment.
yeah. That's cool.
Yeah, so it really helps like cement some of how monotreme characteristics evolved, but also why was their range of that time.
Yeah, it's really
Very
interesting. So yeah, brilliant discovery. I love monotremes. I've always like specifically loved echidnas for some reason. I don't know why, but yeah, I'll switch off that. They're just always been some of my favorite animals. Moving swiftly onwards. Did you want to? What did he say we'd do next?
Oh, I forgot we.
Penguins.
Yeah, we have the
Penguins.
theropod footprint as well.
I thought we weren't going to mention that.
Okay, we're not going to mention that.
Wait, you said to do like the certain ones and then
Yeah,
finish.
because we
Okay.
have limited time, so.
Okay. Yeah, you can switch back to this.
What's this penguin called? I just saw the name. Kumi.
Yeah, I called it Kumi Manu. I don't know if that's how you actually say it.
Oh, and then you got Petra. Oh, sorry. Petrodiptes.
Oh, is that the bird?
this one-
the kestrel they found.
No, because
No, these are penguins. These are all
found two.
penguins.
Oh, they found a new
They
kestrel as
found
well.
Oh,
yeah, that's recently. So basically here, they've looked at this formation in New Zealand, Paleocene. So it's 55.5 to 59.5 million years old. Yeah, that formation on South Island. And they've named two. Maybe.
Meraki for me.
There's so many comments about pronunciations. I don't want to risk it. Anyway, so the Kumimanu genus was named back in 2017, and then they've named this new species belonging to the genus. So Fordycii, if that's how you say it, is the new species, and it's possibly the biggest penguin ever, which is pretty cool.
What is it like? Slightly bigger than emperors.
No, that's the other species.
okay.
So the other one they've named,
I've seen the paleo one. It's really cool.
Petrodiptes, yeah. This they say that was slightly larger than the extant emperor penguin, and then they actually found a fragment of a smaller species, but they haven't named that one. So these are the two we're looking at here.
That's so cool.
So this is the Kumimanu genus. I think this is the original species. Oh, I love this. Actually, this is the best. The penguin scale. So here it is compared to Danny DeVito.
Oh my
actually taller.
God.
Actually taller than Danny DeVito. It's crazy. So yeah, there's the other species they named back in 2017. This is the new one, even bigger. So yeah.
Oh, and then there's the slightly
Little
yeah, so that's the
penguin.
other one.
I like the little
Little
comments,
penguin.
the now not quite whopper,
What is it? Oh yeah, I didn't see that.
Where is that?
New not quite whopper.
previous whopper,
Previous whopper. The
new-
suit added 45 kilograms.
then the new whopper.
New
Little
whopper.
penguin.
Not Star Serving Burger King.
Nice penguin. Yeah, penguin burger.
Gosh,
My God.
they have to do somewhere. Someone's got that.
But Paleocene as well. Like I didn't realize how early
Yeah, I'll get my
penguins
notes up.
evolved.
Yeah, so that's the thing. I don't know if they've realized now. At least the penguin lineage probably evolved in the late Cretaceous. I believe. I think the duck
Alongside the
lineage also
Hesperornis?
did. I mean, I don't know if they'd been aquatic. They definitely evolved very early on
Yeah.
in the Cenozoic, if not in the Cretaceous.
Do we know what from?
Third.
Yeah,
Do you know what
some
we
kind
call
of
it? It's
dinosaur maybe.
Some sort of like Hesperornis? Like
I don't
some
think
of-
they'd be related.
Really?
No, because
That's its own
quite
thing.
separate.
Oh, it would be interesting. They're diving birds, so.
But yeah, basically, so yeah, the mass of between 148 and nearly 160 kilograms is the estimate. They've just gone for an average, though, I think. Let's see. Let's actually look at the material.
It's funny.
The material they've got, it's not. you know, it's not like full skeleton or anything, but it's decent. Complete neck vertebra, parts of the pectoral girdle, nearly complete humerus, part of a hind limb, both kneecaps, interestingly. For Kumimanu, the new species. There it is. End of a right femur and a shaft of a left femur. Go back to that one. Where was it? There. It's funny.
Can we see the paleo art?
Oh yeah, actually that's a good point on this one. So this paleo art is by Simone Giovanardi. But yeah, so here's this is Petrodiptes, and then this is Kumimanu Fordycii. It's just towering above them. It's really cool. But yeah, it has a lot of very interesting implications for penguin evolution. I was reading about in the paper. I got really interested in this paper. So yeah, they suggest like it sort of has the complete opposite trend to other marine animal groups. So whereas like cetaceans, pinnipeds, which is like seals and sea lions, and what's the other group they looked at? Sirenians, I think as well. Wait, no, is it Sirenians? Hang on, let me look through my notes. But basically, whereas they reached the maximum sizes, at least in cetaceans and pinnipeds, started off quite small, reached their maximum sizes later on in their evolution. Like the maximum size of cetaceans have been reached today with the blue whale and other large baleen whales, but penguins like immediately got huge. So they I mean,
ecological niche, didn't they?
that's what they're saying, is that they might have been outcompeted by pinnipeds evolving, so like by seals and sea lions evolving. I'll look at specifically what they say, just so I don't misremember anything. But they're very close. Yeah, both of them, or Kumimanu Fordycii is very close to the root of the penguin evolutionary tree. So it seems, very early on in the evolution, they immediately reached the upper size limit for the penguin body plan. So it could be something to do with them evolving more efficient thermoregulation, the authors also said. So being able to like spread across the southern hemisphere, look for food in colder and then deeper waters, and letting them get access to larger prey items as well. And then, there's that contrast to other marine mammals. Well, two marine mammals. They're not marine mammals. So pinnipeds date to the Oligocene, but the clade did not reach their peak body sizes until the late Miocene. What's Sirenians? Sirenians, that's the manatees and dugongs. They date to the early Eocene, but they didn't reach their peak body sizes until the Pliocene. And cetaceans date to the early Eocene, but only reached peak body size close to the present. But then penguins are the opposite way, where they immediately reach their peak body sizes. There's obviously like different limiting factors. So they say ovipary, laying eggs, could have been a limiting factor in how big they could get. And possibly also that penguins were already highly adapted to marine diving before they lost flight. So it seems like the earliest stem penguins were volant. So it means they could fly. Wing-propelled divers, similar to orcs. And then the loss of flight let them like suddenly grow even bigger. They weren't limited by that. There was this limited window of opportunity where they could get really big and spread around and have access to all these food sources. And then it seems that the pinnipedimorphs, they say, so the seal clade, started evolving and they spread through the southern oceans. And the giant penguins possibly went extinct due to competition, the pinnipedimorphs, because there's no overlap between the largest penguins.
After KPG,
that
opens up a lot, doesn't it?
Exactly.
And then once the mammals do start filling it in,
taking over
that's
their
really
world.
Interesting. So they just straight away took this opportunity to get massive, and then the mammals took over. So,
I wonder how
paper.
widespread these large penguins were, because this is New Zealand.
New Zealand has very good penguin
distinct
fossil record.
Yeah, that's what
Very
they're saying.
good.
They're saying New Zealand is like the hotspot of penguin diversity.
I don't know if you know the
fossil.
fossil YouTuber. Is it
He sent me one of their videos.
Malambo? I apologize for getting your name wrong. I'm a very big fan. But he found a penguin body and he acid digested it, prepared it
cool.
beautifully. It's amazing. The video is insane. But
I think you may have. I think you should.
he finds all the crabs.
Yeah, yeah.
Malambo. I really apologize for the the pronunciation, but
Yeah,
I
that's
just wanted
so
to bring
cool.
that in. Like, New Zealand has a hotspot for penguins.
I'd love to go foss hunting.
I want to go
Yeah,
fossil
go and
hunting
find
there
a giant
so
penguin.
badly. Just you know, you can find really good plesiosaur remains there.
Yeah, well,
Really good plesiosaur remains. Isn't Kaikufili?
Petit
Oh.
Fulu.
Not Pitifulu.
Yeah,
Kaiku-
Kaikufulu.
Kaikufulu is from
Yeah.
New Zealand, isn't it?
That's
So,
not a plesiosaur.
No, what am I
Most
thinking
this-
of? What am I
Like,
thinking of? The one that was
The one on
attacking.
Traceroid Planet.
Yeah.
Yeah, I know the one you mean. I think it's New Zealand. Mosasaur.
No, I'm not thinking of most of the plesiosaur is attacking.
Oh.
Oh, I think of a name of it.
I've forgotten his name.
It would have been an elasmosaurine.
Yeah. Anyway, it is now past. What do you want to cover next? Do you want to do the?
I think we should leave the croc because it will be blasphemous if we don't do Dunkleosteus.
Okay, shall we just go? Or shall I do the Therizinosaur thing quickly?
Do you know
then
what?
the
I
dunk,
might do
or,
I might do the Colossus next week. Because
or the week.
the week after,
yeah.
because that's actually quite really interesting.
And then we've got this as well. Okay, I'll very quickly. Can you take it off for a second? Very quickly cover about this Therizinosaur paper came out recently. I was very
Another
interested in
Nature
this. Yeah, Nature again.
Yeah, we've had
Nature are
the-
just going for those paleo papers, aren't they?
Yeah. There's not too much to say about this.
What's it from? The specimen?
There's
Is it
no
actual
specimens.
Therizinosaurus?
They look. It's just analyzing like finite element analysis. A big survey of different Maniraptoran claws.
Oh, sentence on it.
Yeah. Very cool.
we had to look
Um,
at Therizinosaur
Yeah.
cast recently, didn't we?
Oh, I wish we could bring that here. It'd be so cool. Because
Oh,
I was
we
thinking,
could
like-
get photographs for it.
I've got,
yeah, I've
I've
got
got a
some
couple
photos.
photos of them.
we got photos with it.
Oh, we can
Hmm.
ask tomorrow if we can take it out and record it.
Possible.
I'll have a chat with the.
Okay.
I'll have
We'll,
a chat
we'll
with
see.
the
If that's successful, then we can put in a bit here.
Yeah.
Anyway.
just waving it around.
Because the thing is, it is like a crazy. It's kind of thin, isn't it?
Yeah, in
I was
comparison
surprised
to
by
what
how
I'm seeing
thin it
right
was.
there.
So that's sort of the point of this paper. They basically did this big survey of Maniraptoran dinosaurs, non-avian Maniraptoran dinosaurs, pretty sure. Yeah. Specifically looking at Alvarez-sauroids, so
Mononicus.
Mononicus, and Therizinosaurs. So let's. Here we go.
Ooh, that's a nice figure.
Yeah.
Oh, there's cat.
What?
The figure below this.
Oh, this one. What's
Got
that
giant
looking at?
ground
There's
sloth
a
on
sloth.
it.
Yeah, like
Careful, man.
ecological analogies and things. But the really okay. So basically, what they did finite element analysis, where you kind of test out like how these claws would have performed under various stresses, and then they plotted.
Sorry, which different scenarios do they put it under? It was just
Oh
at the
yeah,
top of that
yeah.
figure.
So they look at piercing,
Piercing.
hook and pull, and scratch digging.
I've been looking at a lot of FEA diagrams like
Yeah.
that lately.
And they test Alvarez-sauroids and they test Therizinosaurs. That's the ones that they're really interested in, because they say like, yeah, these early diverging Maniraptorans, what were they doing? These massive, in the case of Therizinosaurs, massive claws, and in Alvarez-saurids, the derived ones, they like reduced their digits to just the one functional digit with one claw on the end of it.
And it looks like they're like mainly just going for the scratching and digging slash
no.
piercing.
No, the
I
hook,
mean-
the Alvarezzosaurs, they're hook and pulling. You're looking for blue.
Oh, you're looking for
Hamza.
dark blue.
Yeah, blue.
Oh, sorry, I was looking
Blue
for
is
like
best.
green and red.
Hmm.
No,
What do
that's
they
where-
say?
That's
Wait,
where
can we
I'm-
go up? Go up.
Yeah, so
Yeah, that's
bottom
where
piece
it's
is stress.
stress.
Oh yeah, that's what I mean. Like the stress is mainly around scratching and digging,
Oh,
hooking for
okay.
the Alvarezzosaurs.
But-
Alvar.
But what they find is that like, yeah, the basal ones, the kind of, piercing, hook and pull, whatever. And then in derived Alvarezsaurids, so Mononicus, Linhenicus, they do seem to have been
Bit better,
performing
yeah.
well under scratch digging. So they say, yeah, they probably were digging like termite mounds and such. And that's not surprising because that's what we've thought for a while. So this sort of adds more evidence to that kind of behavior. But then the really interesting thing is
Yeah,
the
look-
Therizinosaurs.
That is
Oh my
That's
god.
what-
Because
It's like a
yeah,
Christmas
it's really
tree.
striking when you look at this. Basically, what they find is that the basal, the early branching Therizinosaurs, Earlyonosaurus, Ankylosaurus, Vulcarius, they're fairly decent at all of this. Or specifically hook and pull, they're pretty good at. And piercing, they say, is not too bad. I mean, it looks bad there, but they're saying, yeah, hook and pull seems reasonable. That kind of supports the idea that they're using it like, they say an ecological analogy is like Megatherium, like giant ground sloths. They're using these claws to pull at vegetation. But then you get to Therizinosaurus,
Yeah, and it's just
and it is
wow.
awful at all of them. So they say it has these massive unwieldy claws, and these obviously, well, like as the researchers say, when they're put, like they can't really be regularly being used for functions that are putting them under stress, so they're more likely being used for things that don't involve stress, such as maybe sexual display or warning intimidation displays. And that's why they got so massive compared to other Therizinosaurs, and they got like this scythe shape, and they got so thin because they were sexually selected for. Like the bigger the claw, more attractive they were to a mate, and then that sexual selection takes over. Kind of acts against,
with it.
yeah,
Then how would
acts
you
against natural selection.
try to work that out? You'd have to look at the carpal bones and have the wrist bones to see if there's
I think
any,
they do that a bit.
any
They,
like
they
degree
do-
of motion.
Oh, well, like in the Bellasaur.
Yeah.
they do that. I didn't
But,
read that
yeah,
section
obviously-
in detail.
Their claws are way too thin for any lateral loads.
Yeah,
And yeah, that's just completely lit up like a Christmas tree. Like if you see the grey bits on the very end one on the right,
You
that
can-
basically just means it's completely
Oh,
gone.
yeah.
That's way
you see
past.
the grey bits on the first one as well.
Yeah, there's a bit there.
yeah. They just say they tested all of these the three behaviors, and they say that in all of them the claws just risked structural failure. So they weren't.
The Jurassic World got it
You know.
wrong again.
So I say that in the 7 Days of Science. I was like, so defense attacking on the dinosaurs.
Like Ankylosaurus.
Jurassic World. Yeah.
Eating a deer.
That's not possible.
Like I've been looking at my Spinodon
Yeah.
PA charts, and like while that does light up a little bit under certain conditions, nothing like that.
Yeah. It's really interesting because I don't know why is no one's really done this.
Yeah, the material is very rare. That's the problem.
Yeah.
Yeah, and to be fair, there's not been much on Theropod Manus in general.
Hmm.
Like, in
But
terms of
it's
stress
really
forces.
interesting. Really cool paper.
Yeah.
Gets
Is
spliced
the-
in nature again.
Is the new Japanese? There is one there.
It's not here. Apparently, Therizinosaurus is not there, but they do have a claw for that, don't they?
Yeah.
Because they mentioned some functional stuff there, and they say that I think they looked at Therizinosaurus as well, and they said, oh, it could be for hooking vegetation, but yeah, apparently not, because that's the one, right?
Okay,
hooking
so-
It's vegetation.
But okay,
Yeah.
we've seen the hook and pull, but there must be a degree of it probably not using its claws, but using its phalanges to grab.
maybe, but then I don't know. It's really interesting that they have these massive and apparently useless claws attached to their hands. Like, what were they doing? And I think display makes sense.
Yeah, too.
But then,
I mean, it definitely would have helped
Yeah.
ward off predators as well.
Yeah, look at
Yeah.
peacocks.
yeah, exactly. That's a classic sexual selection idea.
No, what I mean in the sense
example.
of scaring away something.
Yeah, or just display
Yeah.
and everything. Yeah, so I guess that to me at least, that does make sense as an explanation for why this dinosaur looked so ridiculous with
Yeah.
its massive claws. Like, why would an animal have claws that large unless it's like whenever you have bizarre structures in animals, it's usually sexual selection.
Especially if it essentially hinders them.
Yeah, exactly. Like strap-toothed whales. Love that example. The males have incisors, or no, they don't have incisors. One of the teeth, they just like grow over the snout of the males and like keep the jaws shut, so they can't open them properly. That's like the best example of sexual selection working against natural selection, and seems to be what happened in the Therizinosaurus as well. But then non-Therizinosaurus Therizinosaurs all seem to be performing fairly decently at other things. So they, at least according to this study and their results, they say other Therizinosaurs, kind of like giant ground sloths, using these claws, and then Therizinosaurus itself just got a bit carried away.
So
Sexual selection took over, and
does that make the idea of, like you just mentioned, with a strapped whale? What was it?
yeah, strap-toothed whale. I'll
Strap-toothed
find some
whale.
photos.
Does that mean that the Therizinosaurs were already going out, or they were leaving? They're like,
It's just
Not
like
at
a
But
really
you got to think, right? So
weird.
you mentioned peacocks earlier.
yeah.
They get caught out by tigers all the time because they can't lift off as well. Like you think, people don't think about antlers as much because like people don't think of But
Ah.
antlers do not help at all. They live in forests.
Hmm.
Have you tried moving around a dense forest with jutting out structures?
That is another example they talk about actually. Megalosaurus.
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 Not Megalosaurus.
I say it both ways. and it
Megalocaris.
confuses me. Yeah, but that's an idea for why those antlers got so massive. It's like, yeah, for display, and then it would have hindered it. So
Because it's basically saying, I'm so successful that
yeah, exactly.
I can do this and it doesn't matter.
Yeah, so that's all I wanted to say about that study. It's very interesting. My favorite dinosaur was a
Boring.
bit useless. No, it's more interesting, I feel like. Look at that.
Come on.
That's cool though. They weren't like they had these massive useless things on their hands. That's fantastic. Love Therizinosaurs.
Edward Scissorhands.
Yeah.
I couldn't do that.
True.
All right, so that pretty much covers Therizinosaurus and its silly claws. Let's go on to the big news of the week.
Hot topic of media.
They shrunk the
Who
dunk.
shrunk it?
I love so many of the comments on the 70s Science video are so good. There's one, I don't remember the name, but I can't even begin to think about how they shrinkle the dinkle. I'll find it. At some point. I'll put it in. Thank you to whoever left that. It's been stuck in my head for like a week now. So.
Lacodermii.
Yeah, basically what happened here then in this study?
So,
There we
yeah,
go.
it's just
Oh my
Tragic.
gosh.
Although, do you see what I was saying to you earlier, Hamza?
does
Like,
look
the
off.
skull isn't scaled right there. That's not the same
dorsal
size.
fin doesn't
Yeah.
make sense as well.
Yeah, because I know like basically what they mostly find are the skulls and the
Yeah,
the
we have actually got
thoracic
some
armor.
really nice skulls for it.
Yeah, but they're saying the skull size, obviously that's what we have, that wouldn't change, but the overall shape of the body and the length especially is a lot.
The dorsal fin does not
Different.
look right. That looks weird.
No, I think they have
Yeah.
done a lot of research on, I mean, so yeah, you said yourself that the paper is enormous.
Yeah, so because I said earlier, most
Just keeps
body
going.
size papers and all that sort of stuff are usually fairly short because they rely
Yeah.
on established equations or maths and simulations. They don't actually last that long. But this is creating an entirely new
Yeah.
way of
New
estimating body
method.
length
Yeah.
for fishes, which is based on the orbit to opercular length.
Yeah, so the opercular is one of the coverings, right, of the
Yeah.
gills. Am I
Yeah.
correct there?
So when you say this is a new revision to estimate fish sizes, is that only for the placodonts?
Placodons?
Placodonts?
Placoderms.
Placoderms.
I think it's no, I think it's more for basal vertebrate fishes. I think you not sure you might be able to apply it to other basal ones, but it's because a lot of the older estimates for Dunkleosteus were actually based on modern Salacians and other fishes,
There we go.
and obviously I mean, have you seen some like shark
Yeah.
faces? They got really pointed, so measuring those gave it much bigger estimates than proper, and also yeah, well, you can see their shark face.
Yeah.
But we actually have some really good Arthrodire skeletons, and I believe this study only focuses on Arthrodires, which is a group of placoderms.
Yeah.
Yeah, we've got
The
some really nice fossils of
Dunkleosteus
them.
belongs to, right?
Yes, yeah. What was I going to say? So those were used to essentially create, I
Yeah.
imagine,
Okay, that's it.
regression equations to estimate the body size, and so it went from being around 5-6 meters to now 3-4.
Yeah, did it say some of the largest estimates were like up to 10 meters?
I think
Was
that
that-
was a long time ago now. Definitely not in the
Okay,
last
yeah.
5-10 years.
Right.
Yeah,
Yeah,
definitely
so
not.
it's gone down a lot,
Yeah,
significantly, and it's a very different shape to what older reconstructions showed.
it's just because like these Arthrodires are a lot shorter in body than we used to think.
Yeah. But yeah, it's very interesting that.
Yeah.
I mean, yeah. I don't know. It's
I do want to get
sort of
through
expected.
it eventually at some point.
You can read the
It's just
entire
really
thing.
long. It'd be interesting, I think, because
Okay.
estimated body. I mean, I've been doing that with my sharks, haven't I?
Yeah, that's true.
I'd like to see methods they use for it because I use crown length, which is very different from orbit, and I feel it'd be quite difficult with some animals, I imagine, because skulls can always turn up.
Yeah.
But to be fair, with placoderms, because they're so bony, we do seem to have a pretty good fossil record for. I mean, how Dunkleosteus is only known from its skull.
But
Yeah.
still, for its time, was Dunkleosteus still a
It's
big,
huge. Yeah,
Yeah.
for
still
its times,
big
it's
predator?
very large. I mean, and that's the thing. Yeah, it's smaller, but would you still wouldn't want to swim with it? It's
no,
still
it's
like
still terrifying.
much bigger than. Also, yeah, that's another problem I've seen people point out. That human is 2 meters. Sorry, not 2 meters tall. It's 1.7. Wait, oh no. On a different scale, they use a 2 meter human. Okay, this is a different
okay.
chart. On the other size chart from earlier, they use a 2 meter
Yeah.
human, which isn't too common.
Oh yeah,
Yeah, that's a very that's a basketball player there.
yeah,
And also, yeah, that skull is not the same size as the one at the top.
yeah. Something weird's going on there. Yeah, I don't know.
They must
Perspective?
have noticed that
But
when
yeah,
they went
the
through.
skull is still the same size. They can't change the hair.
No.
So
Yeah, it's still a scary animal.
yeah,
still
and it's still
pretty
very
epic.
interesting. I mean, it's very big for its time.
So
It's still very interesting, and outside of just being a large predator.
yeah, no, it's very interesting and cool that they've got this
Yeah,
this new.
I want to see
technique.
where it can be applied.
Yeah, I'm sure it definitely will be used a lot.
Yeah.
And yeah, I mean, good idea to test
yeah,
on
I mean,
Dunkleosteus.
well,
As famous as that.
very popular. I
Yeah.
feel like I feel like this is still well accepted.
Mm,
I don't think it's caused too much controversy apart from it's smaller now.
yeah, the memes have been good. There's
Yeah.
been
Yeah.
a lot of media attention.
Yeah, so it's
on
gone from being really scary to now. Would you not want one?
yeah,
Yeah,
definitely.
it's really cool stuff. I imagine it took a lot of work.
Yeah,
get
it's
this
only
done,
by
yeah.
one author.
Yeah, it
it's
must have taken
crazy.
years.
I'm
It's
looking
so
at
long.
received on the 6th in December,
That's
revised
pretty good.
in
That's
January.
very fast.
I do need to probably read through it because I want to know how they came up with that method.
Yeah, I guess just doing
Yeah, different,
statistics and-
seeing
Mm.
what produces isometric.
yeah,
Yeah,
it's very cool. So that's pretty much everything we want to say about Dunkleosteus.
yeah.
I think. One more thing left to do, I believe. You want to take this off?
Oh, that was my dissertation.
That's fine. We just wanted to talk about this new book here.
Yeah.
Yes,
Very
going from
briefly.
the Dunkleosteus Oceans to
We all have copies.
ancient sea
Yeah.
reptiles.
Well, I don't want to borrow it from someone else.
Yeah,
I
I
want to read
know.
my own.
we were all excited about this book for so long.
Yes, it's been a while since marine
So-
reptile books. You give me
It's
that.
got that book smell.
Wait, hang on, give me it.
It's good.
Oh, you're right.
It is good. It is very good. So it's by paleontologist Dr. Darren Naish, a friend of the show, I think we can probably call him.
Yeah.
Been on in a few videos,
Oh,
Yeah,
I've not
there's
seen
amazing
that
paleo
before. That
some paleo artists I'm not too familiar with in here. But yeah, basically it's ancient sea reptiles
Yeah.
covering plesiosaurs, ichthyosaurs, mosasaurs, sea turtles, and
with
and
the
bunch
best one on the front,
Well, that's debatable. I don't know.
you got some cool crocs.
worst
Yeah,
one on the back.
Yeah, okay, no one likes mosasaurs. Imagine liking mosasaurs.
Let me
Honestly.
quickly
We're
show
gonna get
the
attacked
back.
by more mosasaur.
Nice mosasaur skull.
Yeah.
Um,
But it's
yeah, it's fantastic.
we only just got these in the last few days.
I literally
You
picked
got
mine
yours
up
today.
today.
Yeah.
Chimento Rex. I got mine
You
last
got yours
week.
before us. It's so
Yes, I got mine last week.
Well,
Um,
mine came the same day, but I wasn't in to pick it up. But yeah, it just sort of covers their general evolution, anatomy, and then goes through the separate groups and a lot of work.
Yeah, a lot of
But
up to date
But
science.
that's the thing. Nature's done a lot of work on
Yeah.
marine reptiles before. I know it obviously includes some of his research, but it's cool to see it all collated like this.
Yeah,
as well.
it really is. And the ichthyosaur stuff, I've very briefly. We haven't. Well, we should say we haven't read
Yeah.
through it yet,
no, we've
we
only
intend
just.
to.
This
Yeah.
Wanted to,
and we'll
very
yeah.
little time.
yeah,
to
but
have
we
fun.
will be reviewing this in an episode.
yeah,
Probably not next episode, but the one
probably
after that,
cover our
probably.
own sort of sections.
Yeah, and it is from what we've seen so far very, very good. So we'd highly recommend picking it up.
It's very affordable.
yeah.
If you want to
I
get
think-
into paleontology and you like your ancient sea reptiles,
Oh yeah.
100%. Because some
I
of
thought you
the
said 100 quid.
no,
No.
100% get this because a lot of the more experienced books are very expensive.
Yeah.
And this is a really good it's an overview, but also there's a
start.
lot of detail in there.
Yeah.
So I briefly looked over the ichthyosaur section, specifically at the platypterogenes, which is what I'm studying. And
I've looked at the
there's
crocs.
really good information in there. So
Yeah.
it covers every family and all the subfamilies, just going systematically through them. So it's really cool.
One
Very
thing-
nice paleowild.
One thing that's really cool is that Nace actually goes through the weird and wonderful groups as well.
Yeah, the lesser known ones. as
Yeah,
well.
the lesser known
Cool.
ones. So I was literally just flicking through. He talks about phytosaurs, which is very weird. I didn't actually think
And
the
then there's,
phytosaurs actually took over the oceans. Well, went into the ocean. But
Nothosaurs as well, right?
Hooposuchians.
I love them. Basal ichthyosaur relatives.
Yo, look at that reconstruction.
That's so cool.
Yeah,
Here
no,
at
it's
More
just really
Hippos,
nicely laid out and clear.
Yeah.
It's got loads of great figures and pictures.
I swear
It's
a
good
lot of
balance.
these images he's taken there, a lot of them are from the Natural History Museum in London.
Probably.
I've
It's,
seen a lot
I mean,
of
it's
posts
published
of his.
in the UK. It's published by the Natural History
And
Museum.
then
Not all of
in
the
in the
pliosaurs
US
are,
it's
though.
by
Smithsonian.
Smithsonian, but yeah.
So yeah, we'll keep
Yeah,
an
we'll
ait out
get-
for this, and we will
get around
definitely be
to it.
reviewing it very soon. Well, it's been there the whole episode, so just promoting it a little bit.
Yeah.
There we
Goes
go.
back in the back.
Very cool. Okay, so I think that's it. Should we mention what we're doing next week?
No, let's keep it a secret. No, yeah, we can.
Um,
Yeah, well,
I mean, I don't know how many tickets have sold, or
did-
not sold. No, it's free.
yeah,
yeah,
it's free
so-
entry.
Basically, next.
We're coming to a
Exactly.
town nowhere near you.
Yeah, if you happen to be near Oxford, happen to be near Abingdon, we're going to be giving. Well, everyone's going to end up seeing it because we're hopefully, if we can figure out the tech for it, going to be recording a live episode in front of a live audience. We'll be recording it and uploading it later. But we're giving a talk at Atom Science Festival in Abingdon, which I have actually talked about that on the channel before. We said-
Yeah, you've
said
talked
it,
about the specimen you're working on. You get
Yeah.
to see Mr. Benji Thomas's specimen.
Yeah,
hopefully.
it's in the museum where my specimen is, which is really cool. And yeah, we're just going to be talking about
just marine reptiles, specifically.
yeah,
mostly
Cambridge
from,
clay.
Yeah, Cambridge.
Yeah.
stuff.
So to be fair, you might actually see some of the stuff from this book
Oh
in the
yeah,
presentation.
probably. And I'll be talking about my dissertation specimen mainly, so about Grandelius.
You'll be
yeah.
on your.
Yeah,
just
I'll be
crocs.
working on the crocodiles. They're not the treasure crocs that I work on, but crocodiles are some.
Yeah,
Yeah.
I'll be covering just a general overview on pliosaurs.
Yeah, so that's what to expect from the next episode. Hopefully it goes well. Hopefully all the audio and video is all right. But it should be fun, and we'll have even if it's not perfect in
Well,
person, we'll have a video.
to be fair, they
from
managed to set up all nicely with Martil when he did that, and that's available.
Yeah,
That was
true.
via a phone.
Really?
That
Was
was via a phone. That was I
Okay.
think it was Meg who recorded
Oh,
it.
well, it was
Or
done
camera,
pretty
I
well.
can't remember, but it was really well
Yeah.
done.
So, we'll be able to do it.
Yeah,
with
we'll
the
hope-
three
hopefully
cameras
figure
and
it
the three microphones and the lights, I think we should somewhat do better.
and
job.
our 3 shared brain cells.
Yes.
we'll figure it out.
3 smooth single brain cells.
Yeah.
Yeah, we'll work it out.
Doing
But anyway,
Actually, sorry, no, 2 because you can only set up the table.
I do with a laptop as well. That's good.
Yeah.
Mine.
it should be fun. We'll see how it goes, and either way. Oh, also, we'll have a update on my dissertation. We'll do that in the episode after the
Yes.
live one. We're gonna go and actually 3D scan it.
It would be cool if
So
we could show
we'll
the scan.
record some of that. I think
Yeah.
Yeah.
Yeah, my
we'll talk about that in a later episode.
we can have you can chat about your dissertation as well, how it's going
Yeah.
on. Mine, I don't think we can chat about it anymore.
Well, I was gonna say if people want to see, won't be next episode, but maybe the episode after. We had to do the presentations about our dissertation
back in
process
December.
in December, but still, I think it'd be cool to kind of do those.
I could do Charlie's
for the show.
presentation instead.
Yeah, he's doing plants, ginkgos.
Oh,
So-
the Yorkshire coast.
Yeah, but I think it'd be cool. We can kind of show what we've been working on up till when we got in December. So let us know if you want to see that. Yeah, thank you so much for watching. Hope you enjoyed this episode.
See you in Abingdon next time.
Yeah, hopefully. Well,
I would
link
like to do
the-
more of these, like more of the Avignon talks.
Well, let's see how it goes first.
Yeah, yeah. Let's see how it goes.
Yeah.
We did a little talk in a school once, me and you.
Yeah, no, that's
That
fun.
was fun. That was
Yeah.
very, very heavy fossils.
Yeah, we'll
Not doing that again.
need to improve on. Well, I need to improve on my public speak. Oh well.
Should we bring some? Do you have any ichthyosaur material you can bring?
I do.
Awesome.
Yeah, you've got your birds. You can bring. Oh, basal septal. You've got your basal
Yeah,
septal.
I could. Yeah, I could bring that.
But yeah.
Yeah. Anyway, so thank you for watching. We'll see you next time.